Okay, question is, this is November 2020, paper 529702. And the question number 1 is, a student investigate the motion of the trolley on a wooden surface as shown. The mass M is placed on the trolley. A mass P is attached to the trolley by string passing over a pulley. When the mass falls, the pulls the trolley along the surface. The trolley is initially at rest. The student investigate how the speed v of the trolley at the distance d from the initial position of the trolley varies with m. M is the small mass. It is suggested that the relationship between v and m means speed and mass is 2d over v squared, m plus r over pg minus q, where g is acceleration of the free fall, q and r are the constants. Design a lab experiment to test the relationship between m and v. Explain how your results could be used to determine q and m. You should draw a diagram showing the arrangement of your equipment in your account. You should pay particular attention to the procedure to be followed, the measurement to be taken, the control variable, the analysis of the data, and the safety precaution. So this is the question. Now we start the solution. So first, we write that the definition independent variable. Is the mass m which is placed on the trolley. Number 2, dependent variable is the speed v of the trolley which is reached. And number 3 is the constant. So what is constant? Mass p is kept constant, which is hanging with the help of pulley. So these are the 3 definitions of the problem. Number 1, the independent variable m. Number 2, the dependent variable speed. Number 3, the constant mass m hanging with the trolley. And then next is diagram, next heading. So in the diagram, we will draw first a horizontal surface, then here a trolley, then here a pulley, then we will attach this trolley with a string. String is passing over the pulley, and here is the hanging mass P, which is kept constant, and here we have to place the small mass, the variable. Now, distance covered by the trolley from suppose this point to this point is exactly same to the height fallen by this hanging mass h. So either measure this d or measure this falling height. So it's easy to measure. We will clamp here a meter rule, vertically clamped meter rule. This is the meter rule. And here is the stand. Now we have to show different sizes masses, at least 3 masses, because we have to change them. We have to place different mass on the top of the trolley for the different reading. So for the measurement of the mass, we will show here a balance, top and balance, electronic balance, it's up to you. So this is the top and balance. And then definitely we have to measure the speed. So distance is measured from the meter rule and the time is required for the speed. So we will draw here any stopwatch. Then definitely we will label each and everything. So this is the meter rule we will write. This is the hanging mass speed. This is the pulley we have to write. This is the mass place. This is the trolley, right? This is a stopwatch. This is a balance. And these are the masses we have to, yes, label them. So first heading is the definition of the problem. Second is the diagram. And next heading will be the procedure. So the first line we will write apparatus is arranged, assembled as shown in the diagram. Mass M is measured by balance and placed on the trolley. After placing this, release the mass, capital P, which is hanging, and record the time for the P to reach the ground. Then measure the height H fallen by the mass P with vertical clamped meter rule. Repeat the experiment. Take the average of time, T average in second. And then by using the equation, V is equal to distance divided by time, suppose in centimeter per second, is calculated. Next, whole procedure is repeated with different masses M, keeping the mass P constant and using the same trolley corresponding values of T1, T2, T average, H, and V are calculated, are determined. So this is the procedure. Now, after the procedure, we have to write the heading, which is tabulation. So between two lines, like these lines, we have to draw the table, only the headings with units, no column. So first, the number of observation. Second, the independent variable, which is M. You can write in gram, kg, it's up to you. Then dependent variable, which is speed, but we cannot measure speed directly. So before speed, we have to measure the time to fall certain height. So we will write t1 in second, t2 in second, then t average in second, and then we will measure v is equal to d divided by t or h divided by t in centimeter per second, and then we will keep two boxes empty for further required physical quantity for the graph. Now the next is data analysis. This is the heading. So in data analysis, we will write the equation in the linear form. So what is the equation? Look, this is the equation 2d over v square is equal to p plus r over pg minus q. So we will make v in any form the subject of the equation. Okay, I solve here. So it can be written as 1 divided by v square m plus r divided by 2d pg minus q, or 1 over v square is equal to m divided by 2d pg minus q and plus r divided by 2d pg minus q. Okay, look, this is the linear equation. So it can be written p square. This is the final shape, but we can write in better order. So 1 divided by 2d pg minus q multiplied by m plus r divided by 2d pg minus q. Now look, this m is plotted at the x-axis, are required at the x-axis. This is independent. 1 over v square at the y-axis. So y is equal to mx plus c. So this portion is the gradient and this portion is the y-intercept. So in the table, definitely two boxes are empty. So we will write here v square centimeter per second square, and then finally 1 over v square centimeter per second power minus 2. Now we have to sketch the graph. So first of all, we will label the origin, then mass in gram or kg, then 1 over v square in centimeter second power minus 1 whole square. The gradient is positive, y-intercept is positive. We will draw a straight line with some gradient positive and some intercept positive. Okay, then we will write here the gradient of the line is 1 divided by 2d pg minus q, and this y-intercept is equal to r divided by 2d pg minus q. And then we will write the conclusion: if graph is straight line with gradient, we have to mention this, and y-intercept, we will mention this, then relation is justified or it's tested. Now we will look again for the requirement. Yes, we have answered this. Design a lab experiment to test. We have tested, but explain how your result could be used to determine Q and R. So we will write additional. Q can be determined by, look, the gradient, this one, multiplied by 2d is equal to 1 divided by Pg minus Q. So it can be written as Pg minus Q is equal to 1 divided by gradient times d. Now Pg minus 1 divided by gradient times 2d is equal to Q. So this is the final shape. So gradient we can calculate from the graph. D is the distance fallen and P is the mass of the hanging mass which can be measured from the balance. G is acceleration to gravity, hence Q is calculated, Q is determined. Now move to this R. Look, this R over 2D, R divided by 2D, Pg minus Q is equal to y-intercept. So R can be determined by multiplying this y-intercept with Pg minus Q times 2D. So Q is calculated, P mass, G acceleration, D distance fallen, y-intercept from the graph, so R is determined. Now after this data analysis, the next heading will be safety precaution. Now we have to write one safety for the observer. So what is the safety? The safety is this hanging mass will touch the ground and after bouncing, it may hit the observer. So we will collect it in a sandbox on the ground. So the safety is use sandbox to collect mass P on the ground because after bouncing, it may hit the observer, which can cause any injury. So you have to write any possible safety of the observer. And the last one is either write the additional detail or write good design feature or improvements. So 3 headings, anyone. So first, in all experiment, we have to write how to make dependent quantity more precise, measurable. So definitely, if the distance d is very small, if the height fallen is very small, we cannot record time accurately, so the speed will be not accurate. So we will write for reasonable value of speed gained by the trolley fallen height h of mass p must be large enough. So the height or the distance covered must be the large enough. And the number 2, stopwatch will record the time due to some uncertainties, your reaction time. So we have to improve this measurement. So instead of the stopwatch, use light gates to record time, T1, T2, and then take the average. Number 3, the surface over which the trolley is running, it must be smooth and level. So to check the level of horizontal surface, use level meter, which is also called spirit level, whether it is horizontal or not. And number 4, you can write for the verticality of meter rule, use set square to measure HD accurately. And extra, number 5, whole experiment must be performed in a closed environment because oscillating mass P may change the distance covered by the trolley. So no oscillation in the hanging mass. Otherwise, the trolley will move zigzag, so the distance covered will be different from the actual. Distance measured will be different from the actual. So these are the points, but you have to write first four. One is extra.